Okay, this is the first screencast, and I made it optional, so I hope you're checking it out. This is a follow-up to finding limits. We started talking today about finding limits, but we only talked graphically. This will also talk about how to algebraically find a limit. So I do have a little video here. You may have seen this before. Um, Mean Girls. So let me play that.
Contestants, find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you. The limit is -1. I lost.
That answer is incorrect. Now, we are in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist!
Our new state champions, the North Shore Mathletes.
So maybe you can become a champion mathlete if you know your limits, something you can aspire to. Wouldn't that be awesome? Anyways, we'll learn a lot more than Lindsay Lohan did, I hope. First off, let's talk about graphically. This is what we did in class. And we talked about limits from the left, from the right, and we also talked about how in order for a limit to exist at a point, it had to be the same from the left and from the right. We looked at some graphs like this and piecewise stuff, and well, we had a packet that we worked on. We'll talk about that a lot more in class tomorrow. But what I want to focus on today is algebraically. And there really is 3 steps that you want to do. Try these in order. First, just try and plug it in. If you can plug it in and get an answer, you're done. If that doesn't work, then you got to go to step 2, where you have to simplify. Then you substitute. And your last resort is simply to graph it. So let's take a look at some of these. So first off, here is x squared, which is a nice looking parabola. And if we look at the as x approaches 9, which is way out in here, from the left and from the right, it's going to be a value way up here. And step 1 from our list is simply just plug it in. Easy. Plug it in. 9 squared. 9 squared equals 81. If you can plug it in and you can get an answer, good to go. That is what your limit is. There's no holes in the graph. There's no asymptotes. Nothing. You're done. Those are easy ones. Here's another example of an easy one. Just plug it in. Step 1, plug it in. 3 squared is 9. 2 minus 3 is -1. Looks like my answer here is -9. So at 3, 1, 2, 3, -9. I like it. No holes, no asymptotes. It is a point on the curve, and we're done. I love them when we can just plug them in, but they don't always work that nice. For example here, if I plug in 0, things work on top. I get 0, which is okay. It's the 0 I get on the bottom that's not so great. We can't just plug it in because we get undefined. Now the graph looks nice here, but if we zoomed in, we would see that we have a hole in the graph right there. And what we need to do for this is we need to do some simplifying. This is like step 2. So I'm going to FOIL this. And I still have this -9. And this is all over x. I lose my 9s. And this looks like sloppy. Sorry. I'm going to factor out an x here. And this is what happens. Very nicely, these x's cancel. Once you cancel out those x's, now we can substitute. So if I plug in 0 now, good to go. I get 6, which is where the hole's at. And that's what the limit equals. From the right and from the left, even though there's a hole, we don't care. Let's try another one. This one looks a little bit more messy. I plug in 2, I get undefined. I look at the graph. This is looking like an asymptote right here. It's not a hole in the graph. If I think about 2, x approaches 2 from the left. If I approach 2 from the left, this looks like it's heading towards negative infinity. If I approach 2 from the right, this looks like it's heading towards positive infinity. Are they the same? Nope. If they're not the same, then this limit does not exist. They have to be the same from the right and from the left. This would be an example of where step 1 doesn't work, step 2 doesn't work. We could factor this thing, but it is not going to cancel. So that goes to step 3. Got to look at the graph. The graph shows us that this is a D and E. Oh, and I think I have one more for you. Let me scroll down. This is an example of step 1, plug it in, no go. Step 2, I think we can simplify this. I'm going to factor. And this one's nice because the factors cancel. And once we cancel, we can plug in 1. 1 plus 1 is 2, which shows me that at 1, 2, there is a hole in the graph, but that's okay. The point doesn't have to exist, just the limit. And the limit for that is 2. So that is finding limits algebraically. I hope you enjoyed this. Please feel free to look back on it if you want to check out any of the work. I went pretty quick. And also, below this, if you look down, there is a form that you can fill out with questions. This one was just optional. In the future, they'll be required, and you will have to fill out that form so that I know that you watched it. Anyways, we'll go over this stuff again tomorrow in class, and we'll answer questions. So, have a great night.